day, my name is Richard and a warm welcome to Tutoring with Richard, where we cover the South African school syllabus and native topics. If you found these videos helpful, please consider supporting me on PayPal, Patreon or Buy Me a Coffee. Links in the description below. Today we're going to cover strength of materials in 6. The topic of this tutorial is deflection of beams, example 3.8. Let's get straight into it. Okay, let's read our question. Our question states, a platform is supported by I-beams, 203 by 133 by 25.3 kgs per meter, which is spaced at 2 meter intervals. The beams are simply supported at their ends over a length of 4 meters. The platform carries a surface load of 4 kilonewtons per square meter, as well as a point load of 3 kilonewtons at the center of each beam. Ignore the mass of the beams and the platform. The modulus of elasticity is 210 gigapascals. So, this is just a basic picture of what we are looking at. This is a basic picture of what we're looking at, and between each beam, so between there and there is 2 meters, and between here and here is 2 meters, and between there and there is 2 meters. Okay, so what we need to do, and this is 4 meters. So what they want is the maximum stress in each beam, and also what they want is the maximum deflection of the beams and the maximum slope of the beams. So first, what we have to do, the load per square meter is given, and therefore the load per running meter must be calculated. So we must do a running meter. So here's our beam. It's simply supported at either end. It is 4 meters long. It's 4 meters long, and each at the center there is a point load of 3 kilonewtons. Okay, as we know, each beam, each beam is 4 meters long, simply supported, and 3 kilonewton at the middle point. So, what we need to do is calculate. So how this works is the UDL, so FT equals load per meter squared times area of the pitch. So this will equal 4 times 10 to the 3 multiplied by 2 times 4, because that's the area of our sheet. So it's 2 meters by 4 meters. So now this will equal 32 kilonewtons, because 4 times 4 is 16. 16 kilonewtons multiplied by 2 is 32 kilonewtons, as you can see. So that'll be valuable later. So T equals 32 kilonewtons. Now is load per meter. So there's 2 meters, so it's Ft over L. So 32 kilonewton divided by 2. Divided by 4 actually. So 32 divided by 4 is 8. 8 kilonewton per meter. Now, load per meter equals 8 kilonewton per meter. Now what we need now, we've got that worked out. Now what we need to do is do M max. So M max now what we need to do is M max is equal to WL squared over 8 plus WL over 4. Now, right, so we will need W. Now what we have to do is go through our tables. Let's go through our I-beam section table because these are all I-beams. 203 by 113. Our tables. Okay, so what we need to calculate is first weight is 8 times L, which is 8 times 10 to the 3 times L, which is 4 meters squared, all over 8, plus 3, because that's the point load, 3 times 10 to the 3 times 4 over 4. So this will equal. Okay, let's use our calculators. And we got fraction 8 times 10 to the 3 times 4 squared all over 8. Plus over and under 3 times 10 to the 3 times 4 over 4. And we have exactly 19,000. So this is 19 times 10 to the 3 newtons per meter. So we want it in kilonewtons. So M max is equal to 19 kilonewton meters. Okay, now we can calculate our stress because we have M. Now we just need Y and I. Y for an I-beam, Y for an I-beam is H. So 203, 203, comma 2 divided by 2. Okay, now we must remember that now we need that equals M Y over I. Now we're going to use IX. We're going to use IX. Now, to get Y equals H over 2. So, Y equals H over 2 times 10 to the minus 3 equals that divided by 2, and that will equal 0,1016 meters. Okay, so y is equal to 0,1016 meters. So, what we have to do now is take, now that we've done that, now we have m, we have y, now what we're going to do is get I. So what we're going to do now is 19 times 10 to the 3 multiplied by y, which is 0,1016 divided by I. Now I, if you look on your tables, for Ix is 23,49 times 10 to the minus 6. Okay, so this will equal, put this in our calculator, 19 to the 3 times 0,16 divided by 23 from 4, 9 to the minus. Okay. It is 82,18 megapascals. If we put that in our calculator, that is our stress. So our stress, that is our maximum stress in each beam. So what we need to do now is take this answer, and then we're going to figure out our slope. We're going to figure out our slope and our deflection with this. So let's get to it. 82,18 times 10 to the 6. Okay. Now, our max is equal to our point load plus our UDL. Okay, and this one, this particular one, was W L cubed over 48 E I. And our next one is 5 weight L to the power 4 over 384 E I. 384. Okay. So next step is we do our point load, which our weight of the point load is 3 times 10 to the 3 times our length, which is 4 cubed over 48 times 210 times 10 to the 9 times I, which is 23,49 times 10 to the minus 6, which equals 8,109 times 10 to the minus 4. That's the first one. Now we're going to do the second one. So that's the first one, and then we're going to add them together. So this is 5 times our UDL, which is 8, times 4 times 8 times 10 to the 3 times 4 times 4 to the power 4 all over 384 times 210 times 10 to the 9 times 23,49 times 10 to the minus 6. And that gives us an answer of 5,406 times 10 to the minus 4. Times 10 to the minus 3, sorry. Minus 3. So what we need to do now is take this answer and that answer and add them together. So we're going to add them. 8,109 times 10 to the minus 4 plus 5,406 times 10 to the minus 3 6,217 times 10 to the minus 3 meters. So this is our deflection. Is that much. So our deflection is 6,217 millimeters. Right, so now what we need is our slope. Now, what we need to do is the maximum slope. So, there's the point load, WL, cubed over 48 EI plus numbers. It is squared and 16. And the next one is WL to the 3 all over 24 EI. Alright, so our point load is 3 times 10 to the 3 times L, which is 4 squared over 16 times 210 times 10 to the 9 times 23,49 times 10 to the minus 6. Okay, let's get the first number is equals 6,082 times 10 to the minus 4. Okay, next one is equal to 8 times 10 to the 3 times 4 cubed all over 24 times 2 to 10 times 10 to the 9 times 23,49 times 10 to the minus 6. And this gives us an answer of 4,325 times 10 to the minus 3. And our final answer, we add these two together. We add this answer. So what we do is we add this answer and this answer together, and we get our final answer. So 6,082 times 10 to the minus 4 plus 4,325 times 10 to the minus 3. All equals 4,933 times 10 to the minus 3 radians. And that is the completed sum. I'll give you time to write it down. If you found this tutorial helpful, please give it a like and subscribe. It really helps with the algorithm and to grow the channel. Positive feedback is most welcome. I enjoy reading your comments. Please use the comment section to let me know what topics you would like me to cover in upcoming videos. Be at peace, be kind to each other, and remember, passing well is achievable. Have a great day. Looking forward to seeing you in the next video.